What if computers weren't invented in garages by hoodie-wearing nerds, but actually thousands of years ago in Africa? Well, that is exactly what happened. They were called the African computers, and they didn't even need metal or electricity to work. They used your brain power. You heard that right. Our ancestors harnessed the power of thought and prediction to create some of the earliest information systems in the world. In this video, we will look at 3 examples of how Africans created computers without the use of any electronics. And these are not just regular computers. They can predict the future and communicate with stars that are millions of light years away. So make sure to watch till the end because you will be shocked at what you learn. But first, hit that like button and subscribe so that you don't miss out on any of our videos. Let's start with the Ifa binary system. Ifa is a Yoruba word that means divination. It is an ancient system of knowledge used by the Yoruba people in Nigeria to store wisdom, make decisions, and even predict the future. But here's the mind-blowing part. Ifa uses a total of 256 possible outcomes, which mirrors the way a computer uses an 8-bit binary code to store and process information. To understand how this works, let me explain that in the digital world, everything is represented by bits, which are basically zeros and ones. Computers use these bits to store data, process information, and run programs. For example, a single bit can represent either true or false, yes or no, on or off. 2 bits can represent 4 combinations, allowing for simple codes like A, B, C, D. And as you add more bits, the number of possible combinations increases exponentially. An 8-bit binary code can represent 256 different values, which is exactly how many possible outcomes there are in the Ifa system. In Ifa, the basic unit of information is called a verse, which consists of a sequence of open and closed marks. These marks represent the binary digits, zeros, and ones. When arranged in a particular order, they form a verse. Verses are then grouped together into larger units called ODU, which correspond to specific patterns or concepts. Each ODU contains a body of knowledge that provides guidance on various aspects of life, such as health, wealth, and relationships. But why would a group of people living thousands of years ago need a complex system like this? Well, for the same reason we use computers today to store and process information efficiently. The Ifa system allowed the Yoruba people to keep track of their history, culture, and traditions. It also helped them make decisions, solve problems, and predict the future. It's like having a giant database of knowledge at your fingertips. But that's not all. The Ifa system is still used today by millions of people across Africa and the diaspora. It has survived for thousands of years and continues to evolve and adapt to the changing world. That's a testament to its power and flexibility. Now let's move on to the Dogon tribe and their knowledge of the Sirius star system. The Dogon people live in a small village in Mali, and they have a long tradition of observing the stars and predicting astronomical events. But here's where things get weird. The Dogon knew about the existence of Sirius B, a white dwarf star that is invisible to the naked eye, long before astronomers discovered it with the help of modern telescopes. According to Dogon tradition, they received guidance from a group of aquatic star beings called Namo, who came from Sirius B and shared their knowledge with humans. The Namos are said to have taught the Dogon people about the structure of the universe, the laws of nature, and how to navigate the skies. And the Dogon took this knowledge seriously. They created detailed star maps and observed the movements of the stars with incredible accuracy. One of the most impressive feats of Dogon astronomy is their ability to predict the return of the comet known as the Star of Bethlehem. They claim that the Star of Bethlehem was actually a spaceship piloted by the Namo, and that it returned to Earth every 27 years to collect new knowledge from humans. The Dogon were able to observe the movement of the comet and accurately predict when it would return. This level of astronomical knowledge is usually acquired through centuries of observation and study, yet the Dogon had managed to do it in a much shorter time frame. The Dogon people have also been able to plot the movements of the Sirius star system in the sky with an accuracy that rivals modern telescopes. This system consists of 3 stars, Sirius A, Sirius B, and Procyon. The Dogon are able to track the motion of these stars and predict their future positions with great precision. They have even developed a calendar based on the cycles of the Sirius star system, which they use to plan their agricultural activities. But how did the Dogon people acquire this advanced knowledge? One theory is that they learned it from the Nomos, the star beings from Sirius B. According to Dogon mythology, the Nomos visited Earth in ancient times and shared their wisdom with the Dogon ancestors. The Nomos were said to be highly advanced and possessed technology that was far beyond the comprehension of humans. They were believed to have arrived in a spaceship and to have lived among the Dogon people for several years. During their stay on Earth, they taught the Dogon about the nature of the universe, the laws of physics, and how to observe the stars. The Dogon people have also been able to develop a complex understanding of the Sirius star system. They know that Sirius A and B are actually a binary pair, meaning that they orbit around a common center of mass. They also know that Procyon is a separate star that is loosely associated with the Sirius system. This level of astronomical knowledge is remarkable considering that the Dogon live in a remote village with limited access to modern technology. They have been able to observe the stars and piece together the structure of the Sirius star system without the help of telescopes or other scientific instruments. But let us not forget that the Dogon have also been able to predict the return of comets that visit our solar system only once every 27 years. This feat requires an incredible amount of patience, observation, and mathematical skill. Yet the Dogon have been able to do it for centuries. Next, let's talk about African fractals and algorithmic architecture. Fractals are fascinating geometric shapes that exhibit self-similarity at different scales. They are often created through iterative processes that repeat themselves over and over again, resulting in complex and intricate patterns. Fractals have been found all over the world, but they are particularly prevalent in African cultures. From the layout of villages to the design of textiles and rituals, African societies have incorporated fractal geometry into various aspects of their lives. For example, the Dogon people have built entire villages that follow fractal principles. Their houses are arranged in a way that creates a sense of order and balance while also allowing for flexibility and adaptability. The same principles are also found in the traditional architecture of the Yoruba and the Ashanti people, as well as in the patterns of their woven textiles and wood carvings. But what's even more fascinating is that these fractal patterns are not just aesthetic choices. They also serve a practical purpose. By following fractal geometry, African societies have been able to create systems that are both efficient and sustainable. For example, the layout of a fractal village allows for easy access to resources such as water and food, while also providing a sense of community and social cohesion. It turns out that these fractal designs mirror the way data is compressed in modern technology. Fractal compression algorithms are used to reduce the size of images, audio files, and video footage by taking advantage of the self-similarity of natural phenomena. This type of compression is particularly effective for images that contain a lot of detail and texture, such as photographs of natural landscapes. Research has shown that African societies have been using fractal-based algorithmic thinking for centuries, long before the advent of modern technology. Anthropologist and computer scientist Ron Eglash, who has studied the topic extensively, argues that fractal geometry is not just a coincidence in African cultures. Instead, he believes that it reflects a deep understanding of the natural world and a sophisticated form of knowledge that has been developed over centuries. Eglash points to the Mamprusi people of Ghana as an example. Their mats and cloth often feature intricate patterns that follow fractal principles. The Mamprusi weavers are able to create these designs by following a set of rules that dictate how to arrange the patterns at different scales. This type of algorithmic thinking is similar to the way that computer programs are designed today. Another example is the Kuba people of the Democratic Republic of the Congo. Their bark cloth is famous for its stunning patterns, which are created by carefully arranging strips of bark in a specific order. The Kuba have developed a system for creating bark cloth that is not only beautiful, but also highly durable and resistant to tears and rips. This type of functional design is a hallmark of African innovation and reflects a deep understanding of materials and their properties. So why should we care about this ancient technology? Because it challenges our assumptions about where and when modern technology originated. It also highlights the importance of preserving and celebrating African cultures and their contributions to human knowledge. By learning from African cultures, we can develop new ways of thinking about technology and its role in society. Now you might be wondering why we haven't heard about this before. Well, it's because European colonizers actively worked to erase any trace of African intellectual achievement. They burned down libraries like the one in Timbuktu, which contained priceless manuscripts, and replaced them with textbooks that portrayed Africans as primitive and uncivilized. But despite their efforts, some fragments of this ancient knowledge have survived and continue to inspire modern technology. For example, computer scientists like Ron Eglash have been inspired by the fractal patterns of African textiles to develop new algorithms for image compression. The binary logic used in Ifa has cultural roots that run deeper than just the Greek and Arabic philosophers often credited with its invention. And the Dogon star maps were actually used by NASA to verify the accuracy of their own instruments. In fact, the constellation that the Dogon people called the Great Rift, which spans 2,600 light-years of the Milky Way and includes the Orion Belt, was actually used as a template by NASA to align their telescopes. The Dogon named the 4 bright stars in the smaller rift as the Namos and have stories and myths attached to each of them. Interestingly, each of the stars have a twin star outside the visible spectrum of light. Some of these twin stars are white dwarfs, which are very similar to Sirius B that the Dogon people knew about. Looking up to the night sky and seeing the stars in this Dogon map gives us a unique perspective on the universe and the place of humanity within it. It reminds us that we are just a small part of a vast and mysterious cosmos that we are only beginning to understand. Today, the Dogon people continue to pass down their knowledge of the stars from generation to generation. They use their star maps to predict astronomical events and to guide their daily lives. Their knowledge of the stars is an integral part of their culture and identity and a testament to the power of human observation and curiosity. As we continue to explore the universe and search for life beyond Earth, it's important to remember the lessons of the Dogon people. Their story is a reminder that there is still so much that we don't know about the world and that there is always more to learn. And guess what? Africa's code was always there. It was just overwritten. Thanks for watching. To those of you who made it this far, please comment below with the word rewrite so that we can see who the real fans are. And once again, thank you for subscribing and liking the video. It means a lot to us. Don't forget to check out our other videos and join our growing community.